Hello students, let me explain the topic deviation produced by a triangular prism. Okay, look at this figure now. We have a triangular prism ABC. Okay, and we want to see how the lights get deviated through this triangular prism. Okay, so for that we have a light source. From the light source, light can be emitted and it is passed through the slit. So we can see one light ray is incident on the triangular prism like this. Okay, this is triangular prism and the incident light ray is striking the first surface AB. So for this surface the normal will be obviously this dotted line will be the normal, so we draw the dotted line and striking the point Q. So PQ is the incident ray, Q is the point where the light ray is striking the prism, and this angle I is the angle of incidence, is the angle between the incident ray and the normal. So what happens after refraction through this surface, it bends towards this. Okay, it moves towards this, it bends towards this. This is the original direction of the incident ray. Okay, this QL, which is dotted, is the original direction of the incident ray, but it bends towards this, which is parallel to the base BC. Okay, this ray is parallel to the base BC, and this angle, okay, this angle, which is the angle between the refracted ray and the original direction of the incident ray, we call it first angle of deviation. And this ray strike the surface, second surface AC at point R. Again we can see at this point R, this is the normal, this dotted line, this is the direction of this refracted ray. Okay, this is the direction of this refracted ray, and after refraction through this point R, it again bends further downward, and this is the emergent ray. Okay, and this is the direction of the refracted ray, and this is the direction of the emergent ray, and the angle between the direction of the refracted ray and the emergent ray, we call it second angle of deviation. Okay, now this emergent ray and this incident ray, this was the incident ray and this is the emergent ray. Okay, and this is a ray, refracted ray inside the prism. And if you can see the direction of the incident ray, then this would give the direction of incident ray. If you can see the direction of the emergent ray, then this dotted line would give the direction of emergent ray. So angle between the incident ray, angle between the direction of the incident ray and the direction of the emergent ray is delta, and which is the total deviation. So total deviation is the angle between the direction of the incident ray and the direction of the emergent ray. Okay, so from here we got delta 1 and delta 2, and delta 2 is this is delta 2. Obviously this has to be delta 2. Okay, opposite angles, this has to be delta 2. So from there we can write this delta exterior angle is equal to the sum of the opposite interior angles. So delta can be equals to delta 1 plus delta 2. So from here you can write total deviation delta is equal to the delta 1 plus delta 2, and this total angle of deviation depends upon following factors, three factors. First, it depends upon the angle of incidence. Okay, it also depends upon the angle of prism. Angle of prism is this angle, and it also depends upon the refractive index of the material. Okay, it depends upon the refractive index of the material, and since the refractive index depends upon the color of the light, we know that the refractive index changes with different color of light. So angle of deviation also depends upon the color of the incident light. So we'll study about this in details, okay, in the next video.